This picture is not exactly new. It's just a Venn diagram with one more circle so that there's 4 subsets shown. I'm calling the universe U and the sets capital A, B, C, and D, the subsets of the universe. So what we're doing now is more examples using some of the same problem-solving techniques and formulas that we've already seen, but with a few more subtraction steps. All right, so let's see what the problem is asking here on this example. So first of all, I'll let you know that there are 18 dots. The set U is the numbers 1 through 18. They're scattered around inside that box. The bracket around 18, square brackets around 18, is another common way to shorthand write the set 1, 2, 3, all the way up through 18 that you'll see in some combinatorics books and papers. So the question is, how many elements are in U, but not in A, B, C, or D? Not in any of those. So we're looking for that the union, A union B union C union D, complement, the bar over it, counted, the absolute value bars on both sides. So that's actually not a hard problem at all looking at the picture, right? If you can, you just look at the picture and count them, and you see that in A union B union C union D complement, that's just 1, 4, 16, and 18. There's 1, 4, 16, and 18. Those are the only 4 dots not in those colorful circles. So the answer is going to be 4. But we want to see a method that works when there are too many to just count by hand. So this is again where what we call it is inclusion, exclusion, because first we include everything. So we include the whole universe U, and then we try to exclude each of the sets that we don't want to count. So we subtract the number of things in A, B, C, and D. Then we've subtracted too much because they overlap. Every time they overlap, we subtract something too many times because we subtracted both times. So we add back in the intersections. A intersect B, B intersect C, and so on. All the possible intersections. And at this stage, we might wonder how many things are there to add back in there on that second line. And it turns out that Pascal's triangle helps us keep track to make sure that we did the right number of calculations. When you subtract just one set, it's the number of sets, the number of subsets were 4, capital A, B, C, and D. And so when you subtract just one of them, you'll do that 4 times. You can think of that as 4 choose 1. When you add back in intersections, there's 2 at a time. And so we'll be choosing 2 out of the 4, and there's 4 choose 2, or 6 ways to do that. So, and there they all are, A intersect B, B, C, A, D, A, C, B, D, and C, D. All right, now we've added back in intersections, but we added back in some things more than once. When there's a triple intersection, we just added it in more than once. So we have to subtract the triple intersections. So we subtract A intersect B intersect C, and in fact we subtract all the triple intersections. So we subtract 4 possibilities. 4 choose 3 is 4, and there's 4 possibilities there. Remember the 4 there is because it's just A, B, C, and D. Capital A, B, C, and D. And then finally, we've subtracted too many times once again. We have to add back in the 4-way intersection. And that's all the subsets intersected. There's only one of those to add back in. So those circled numbers, just to be clear, those are telling you how many calculations to do, not the actual values of the calculations. Here's the actual values of the calculations. There were 18 elements in U to begin with. then there were, in the 4 sets, 7, 7, 8, and 7. You can go back up and look at them, or print it out if you want. Then in the two-way intersections, there were 4, 4, 2, 5, 4, and 4. In the three-way intersections, there were 3, 2, 2, and 3. Those are the hardest to see. You have to look real carefully to see a three-way intersection because it's confused with the fourth circle. But then you can look in the very center, look back at the picture once. The four-way intersection has the numbers 9 and 10 in it, in the very center. So there are 2 of those. And you add that back in. And then add them all up, comes out to 4, which we already knew by looking at the picture. But I just want to demonstrate that it does work. All right, let's do this with an example problem. So, it says we are purchasing a bag of 40 donuts. And yeah, let's look back at this on the next video.